Hello everyone, I am Mr. R.B. Deshmukh working as assistant professor in Department of Physics in Anna Saheb Dange College of Engineering and Technology, Ashta. Here we discuss the topic laser. We know laser, that is, it is a monochromatic source of light having same wavelength, high directionality property, extremely brightness, etc. etc. These are the characteristics of laser. Here, the Ruby laser, which is a solid state laser invented by scientist Theodore Maiman in 1960 in USA. So, now we are going to discuss the construction and working of this Ruby laser. So, this figure shows the construction of Ruby laser and here is the working of Ruby laser. Now, in construction of Ruby laser, the main part of this Ruby laser is a Ruby rod. This is a ruby rod which is made up of aluminum oxide in which few aluminum ions are replaced by chromium, that is the percentage of chromium is 0.5% in ruby rod, though the percentage of this chromium is only 0.5%, but it is an active part of this ruby rod. Okay, this ruby rod, it is a cylindrical rod having 4 centimeter in length and 0.5 centimeter in diameter. Okay, the both ends of this ruby rod are grounded and polished in such a that the both ends are exactly parallel to each other and perpendicular to the axis of the rod. The one end is a fully silvered, acts as a fully reflecting end face, and another end is a partially silvered, acts as a partially reflecting end face. Around this ruby rod there is a helical xenon flash tube which is connected to power supply, which provide energy to the ion, that is chromium ion, get excited. Okay, so the part of energy is used by chromium for the lacing action and remaining it heats up the apparatus, so that to maintain the temperature of this ruby laser it is immersed in a reservoir containing coolant, that is liquid nitrogen. Here is a coolant. Okay, so from this construction here is a partially reflecting end face, we get the output as a laser. Okay, so how we get this output as laser? So we move towards the working of ruby laser. Okay, E1, E2, E3, these are the energy levels of chromium. The xenon flash tube provide energy to ion get excited. Okay, so light absorption of this is 5600 angstrom. Okay, so ion get excited and move from ground state to excited state. So for there are four transitions, that is pumping transition, radiationless transition, spontaneous transition and laser transition. The transition one is optical pumping transitions, that is the excited ions give up part of energy to the crystal lattice and remaining to the metastable state. Second transition is a radiationless transition. Now third, that is spontaneous transition, that is we know that the metastable state having relatively longer lifetime, that is approximately 10 raised to minus 8 second. So the energy provided by flash of xenon tube, the ions get excited and move towards the metastable state. So number of ions in metastable state get increased and the number of ground state get decreased. So the probability of spontaneous transition is high at any moment, and it emits the photon of wavelength, that is 6943 angstrom through this spontaneous transition. Now last, that is laser transition or stimulated transition. Okay, so the stimulated radiation along the axis starts dominating due to the multiple reflections inside the ruby rod. Those reflections along the axis grows in strength and that burst through the partially reflecting end face. That is output. We get here output as a laser of wavelength 6943 angstrom. A stage is reached where the population inversion caused by one flash of xenon flash tube. Okay, so we get the output as a laser of wavelength 6943 angstrom. So this is about the construction and working of ruby laser.